first formal topic, so which is about strategy. So before we start our first formal lecture, so I have 2 points for me. So first, we have many interesting topics coming this week and also in the next few weeks. And it's also very important for us, you and me, we learn and think together. So there is no stupid question in this class. So if you have any questions, anything you feel not fully clear, for example, you need an example, so you can just raise your hand when I'm talking, either in the middle of the lecture or after the lecture, talk with me. Ask your question, solve it now. So there's no stupid question in this class. Don't be afraid of raising your hand or speaking. The second is we are going to use WEEK2. Sometimes we're using WEEK2 for our class practice. Concepts, theories, frameworks related to this digital business is very important for us to understand the digital business phenomenon, the complexity. But the difficulty, I believe everybody has had experiences in your past 2 years, is how to apply them. So our class practices will provide those kind of guidance and also opportunity to practice how to apply concepts and theories into real case studies, also in our seminars. So to join me using WeBooks or either speaking up in the class. So this, our first formal lecture is about strategy. What is the strategy? So you may have known this concept from somewhere from your other classes or from your reading, or you may not know this. You may just have an ambiguous understanding from what you see, from the news, from your daily life. So think about what a strategy is. So I'm going to give you an opening case study to illustrate what a strategy is like. So strategy is where every company starts, and also that's why we start with this topic. You need to have a goal and you need to have a plan to execute your goal. So that is the start of all the businesses as well as digital business. So we are going to talk about the digital strategy and strategy process. That is the process of developing effective strategy. Let's recall a little bit content from our last week lecture. So I'm talking about the current development, rapid developments in digital businesses. So that digital technology is growing exponentially. And exponential, we mean the more so that number of transistors on computer chips doubles approximately every 2 years. So this may sound like a physical law, but it literally means the speed, you can understand as the speed of our computers will become faster every 2 years. Doubles, the speed will double every 2 years. But if you look at this graph, it may not be that clear in the previous one, but if you look at this one, so the x-axis is the time, so that is the year, so starting from 1995. You will see this is the y-axis is the performance of the computers, or you can also understand our chips. So you can see the performance has always been increasing. But if you look at the point of 2004, so you will see this line start to become a little bit flat. So before 2004, it's steeper. So if you can see the difference that before 2004, the performance of our processing unit, our GPU, so it was increasing like 52% a year. But if you see after 2004, the speed, the increasing speed, kind of decreased. So it's just 21% increase in our computation speed every day. So here comes to the concern that some people started to see, okay, it seems the increase of our computation power seems to be static. So here comes the worry that our computer, our CPUs may not improve as what in the industry we call that GPU tend to be plateaued. CPU tend to be plateaued. The improvement of CPU seems to have reached its physical limit. So the industry tried to look for a solution. So how can we keep increasing our computation power, our computation speed year by year without reaching the physical limit? So to understand this question, to answer this question, here is some technical knowledge we need. So we need to understand the basic, the physical design features of GPU, and so we can understand why today we have the GPU for training the artificial intelligence. So the first, if you look at this is a graph. So a graph of the CPU. So CPU exists in every computer we're using, in your laptop, in your cell phone. So you can see it consists of many transistors. At the core of a CPU, that is central processing unit, you will see there are a core, so this part. You will see there is a core. So it consists of various multiple transistors. So this is how our computer, how our CPU process our requests. But there is an important feature of CPU, central processing unit, is it only processes our requests one by one, which means sequentially. By sequentially, I mean if you send a request to a computer, so think about this. When you send a request to a computer, either you open a file, open a folder, you talk with your friend, you are viewing a film or a blog. So all these requests, your CPU needs to process them one by one instead of simultaneously. But all these tasks can go from the simple tasks to very complex tasks. So all the tasks your CPU can manage. So that is a feature of CPU that is decided. These features have decided the sequential computation, the feature of sequential computation of CPU. So to make the CPU process as fast as possible, even faster. So current approach, the predominant approach, is to make the processing, is to increase the number of process nodes, so these transistors in the core. So the more nodes in the core, the faster the CPU perform. So currently the smallest, the tiniest nodes or transistors are made by TSMC, so that is 3 nanometers. That is currently the most advanced CPU. So these are two things. So the first one is the CPU we just talked about. So it is optimized for general purpose computing, which means all our requests from simple to complex, CPU can process them, but needs to process them sequentially, one by one. But the second one is another solution proposed by NVIDIA. So a name most of you may be aware of. So the second picture is actually a GPU. So this is not the CPU, like the CPU in our computer. GPU is called graphic processing unit. So initially, GPU is used for rendering graphics. So you will see the pictures, you see the film, see the pictures, see the images, see your film. So these are all rendered by GPU. But these two things have very different features. So the idea proposed by NVIDIA is to use GPU to perform the computational tasks as CPU does. So the GPU, as you see, it has another different groups of features. So just now I have talked about central processing unit, that is CPU. It mostly has like the cores between 2 to 64. So that's the number of maximum number of cores you can have in your CPU today. So their cores are usually more complex, capable of handling a wide range of tasks, and also optimized, decided its purpose, optimized for general purpose computing, all kinds of tasks. But for GPUs, just think about when you're viewing a image, a film. You are not seeing all the pixels showing up in front of you one by one, right? So you see the whole image in front of you immediately. So the whole image. So this is a feature of GPU. It often consists of hundreds or thousands of cores. So that is many cores. But their cores are simpler and more specialized, suitable for handling multiple similar tasks simultaneously. So there are many cores. So each core may be rendering one pixel in your image. So they will render, all the cores will render all the pixels simultaneously. So you will see a full picture instead of a partial image. So this is GPU was initially designed for rendering graphics and video processing. It's not really used for general purpose computing. So this is a difference between the CPU and the traditional GPU. So the idea of NVIDIA, its CEO, Huang Renxun, so he actually come up with the idea is, if we can use GPU to process simple tasks like rendering pixels in images, can we use it also for general purpose computing? So I will show you some of you, when you see those kind of words, especially this kind of technical features, you may find a little bit obscure. So I will show you a short video to illustrate how CPU performs differently from GPU, and why today we are using GPU instead of CPU to train our artificial intelligence models.
All right, I introduce to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100. When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottommost is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over. Thank you.
Okay, so that's the illustration. So for
If you're sharing a hotel room with friends, you're also sharing a bathroom and a mirror and a tub.
So for CPU, what we say the purpose of CPU and also its functionality is decided by its physical features, the physical design, its architecture. So that's decided from the start. So the purpose of CPU is to do sequential computing, as I said. But for GPUs, like rendering a graphic, so you will see it's more designed for what we call parallel computing. So if you see CPU as a highly skilled, high IQ expert processing all those complex tasks, but one by one, you can see the GPUs as a group of workers processing smaller, simpler tasks, they can do it simultaneously. Some of you may have noticed this difference make a difference for AI training. Because for artificial intelligence, we know the basis and the foundation of training efficient AI model is the data. And the data is huge. It comes from internet, from everywhere. So it's a huge amount of data. So if you use CPU to do the sequential computing, it takes a lot of time, a long time to train an AI model. But if you use GPU, it can process simpler tasks, like all those kind of simpler information simultaneously, ready-made information simultaneously. And it can process and train an AI model much faster than CPU. So we can see the difference on the next slide. So when you use CPU and GPU to train an AI model, so the first bar, so this one is if you use CPU, so that's like if you see it as one. The speed, the efficiency, the rate of training with CPU, training the same AI model with CPU is one. You see if you use A100 GPU produced by NVIDIA to train the same AI model with the same amount of data, that is 83 times faster, more efficient than using the CPU. So that's why today, most of the companies, tech giants, they will need the GPU to train their AI models. But there are some changes in the past, and this week I will talk about it later. So that's why all the tech giants, if they want to train their AI model from startups to tech giants, they need the GPU. That is the foundation for all of their AI models. So that's why NVIDIA is currently the monopoly of the GPU market. And its co-founder and CEO, Jensen Huang, he founded NVIDIA in 1990s with two of his business partners. In the beginning, it was just producing GPU for video games. So this is its initial GPUs was Riva and GeForce, but these are only used for processing graphics, rendering graphics. There's no general purpose computing in it. The GPU application initially, conventionally, is in gaming. So the main competitor of NVIDIA is AMD, in discrete GPUs. So in early 2000s, they started to brew the idea. So if we can use CPU for computing, can we also use GPU? And it has so many cores, we can do the same tasks much faster. So this is the initial idea of doing the general purpose computing with GPUs. So he is also calling GPUs as general purpose GPUs, GPUs. So that is the full name. So the CEO, Jensen Huang, is also featured for his fashion style. He always wears the leather jackets. So this kind of development, it's early development and also the conventional business in making GPUs also fueled its traditional largest business segment, which is gaming. It also has three other business segments, which is data center, professional visualization, so producing highly professional and realistic graphics, automotive, so providing those kind of hardwares, also the chips for the what we call the self-driving cars today. But these three segments used to be very small, and the traditional largest segment of NVIDIA was gaming. But this started to change after 2020. So that is when AI, the training of AI models become urgent need for the companies. But if you look at the whole journey of NVIDIA's development of GPUs, so if you can see, it started brewing the idea from early 2000s. So that's thinking this idea may be feasible. And in 2006, they started to organize the development of the toolkit. So as we know much CPU, if we want CPU to do something for us, especially specific tasks, complex tasks, what do we do? So we need to talk with it. So we need to talk with the machine. So that's why we need programming. So some of you may have heard this programming languages. You don't need to know that, but if you have heard of those kind of languages such as Python, like the C++. So this kind of languages is how human beings, the programmers, talk with CPU and ask it to do specific tasks. But for GPU, we don't have something like that. It's just conventionally, it's just for rendering images. So in 2006, Jensen Huang started to organize the development of the CUDA toolkit. So that is a language package. So there's a toolkit for programmers to talk with GPUs and ask it to conduct specific tasks for us. And moving to 2012. 2012, that is the first prominent time for NVIDIA and its GPU. Because in the competition of ImageNet, that is a competition that different teams will develop their own model, train their own model to identify the objects in an image. For example, this is an image of a dog. Can your model recognize it correctly? So this competition is mainly about accuracy. Different teams will compete on the accuracy of recognizing the correct figure in the image. And the winning team, the top team, so excel in every aspect, And the training, so their training used two NVIDIA's GPUs. So that is the first time NVIDIA's GPU started to show its great potential in AI training. In 2019, NVIDIA also made a lot of revenue by using its GPU, producing GPU for, Bitcoin, so for mining. So as you can see, the parallel processing of GPUs is also very suitable for mining Bitcoin. So you just computing the same task again and again. So it made quite some revenue in Bitcoin, but what really makes GPU rise was in 2022 and 2023. That is the AI training race between all those tech giants and startups. Because they just need so many GPUs to train their model, they have to purchase from NVIDIA. But if you look at this journey from early 2000s to 2023, NVIDIA's stock price has increased significantly, but a lot of tumbles in between. This planning of designing and producing GPU for general purpose computing started from early 2000s, but until today it's already over 20 years. Over 20 years to see the real effects, real outcome coming in. So this is what we want to discuss today. Is what is strategy? How long a strategy can be? How long can it take for us to see the outcome of a strategy? So after, as we see, the booming of the AI training race, so we will see NVIDIA also reorganized its business segments. Now the data center has become its core business instead of gaming. So it's also producing even more advanced GPUs than what is used in ImageNet competition. And also, it started to apply its data center capability and also its GPU capability to other business segments. For example, to the professional visualization. So it's a technique literally NVIDIA use its AI model trained using its own GPUs. So to render highly realistic graphics, for example, if you see this difference, so RTX is a technology based on NVIDIA's AI model. So you will see that when the RTX feature is on, so the gaming, the visual of your game will become much more realistic than without the RTX feature. So this is a technique developed by NVIDIA. So if you see one pixel in the picture, so the AI model will guess the pixels around it. So to render those highly realistic images by guessing the pixels around it. And this speed will be much faster because you are predicting what the pixels are like in real life. It also introduced this kind of technologies to facilitate its own universe platform. So different designers, programmers, business partners, they can participate in this platform and do the visualization of their work processes. So this is also what we call digital twin today. So companies, you don't really need to experiment your new work processes in real life because that costs a lot. You can just do it visually, virtually, online, using this Omniverse platform. So this is how it's used, GPUs and also its AI training capability to fuel other business segments of it. So as we can see, how the strategy of NVIDIA, a hybrid strategy that has taken over 30 years to realize, has led to the current outcome. And of course, we can see there are also many tumbles in between, many obstacles. So the processes of developing and facilitating this kind of strategies is always very challenging. So I also mentioned just now, in the recent 2 weeks, we have seen the emergence of the DeepSeek. This kind of challenging NVIDIA's business model and strategies that you need to put a lot of huge amount of computational power to develop, to train very efficient AI model. So DeepSeek seems to be challenging that notion that you need a lot of computation power, you need a lot of money to train a good model. So if you're interested, some of you get interested, you can check during the search on the recent emergence of DeepSeek and why it challenges the paradigm of NVIDIA. Our today's question will focus on the company's development of strategies, particularly digital strategy. So we will look into why some companies' digital strategies outperform others, especially there's so much uncertainty in the market, and also the time for you to see the effect is always uncertain. And what are the possible approaches to assist the development of digital strategies? So 3 parts. Basics, the concept of strategy, digital strategy, and progress to the strategy process. And then we will introduce 2 classical theories about how to analyze a company's external forces to develop, to formulate its digital strategy. And then we will look into the inside of the company. What kind of important internal factors that can influence a company's strategy development? So first, what is strategy? After listening to the story, so you probably have developed this notion. Strategy is not something for short term. It takes a long time. So that's one feature. So as a Greek word, so it originated from the Greek word strategos, generals in command of an army. And it's a term, also a discipline that originated from 1950s. So the strategy, that's the first time you see the combination of strategy and management because the business schools started to develop a module, implement a module called business policy. That is the original word of strategy and strategic management. So from business school. So beginning in early 1960s, there are increased demand of the managers at that time that face increasing competition in the market and also increasing uncertainty. So here comes the demand. Okay, so we need to understand better how to face this uncertainty in the long term. So that's when we see the strategy started to be combined with this term competition, and this concept started to become a regular term used by both practitioners and also the academics. So between 1960s and 1970s, this is a time that strategic management the strategy study to construct its theoretical foundations, and it's fermented as a discipline, an independent discipline, and now it's an important discipline and also module in business school, unnecessary one. So if you look at the academic definition, so Alfred Chandler, he defines strategy as a determination of the basic long-term goals. So this is what we can see from MBBS case of enterprise, and the adoption of a course of action and allocation of resources necessary for carrying out those goals. And Michael Porter, he defined it as a broad formula for how a business is going to compete. One, its goals should be what policies will be needed to carry out these goals. So he actually emphasized a little bit more on the competition, on compete side. And other scholars also define it in their own way. But there are always two important things. So if you look at these three definitions and many others more, you will find there's two common places among them. One is strategy is about long-term goals. And second, there needs to be plans and action for executing those long-term goals. So two essential elements of the strategy. So Henry Mintzberg, so in his work, he tried to identify strategy from our daily practices, from our real life practices. So he proposed the 5 P's for strategy. So these 5 P's are 5 different facets or different manifestations of strategy in practice. This is how you can identify strategy. So usually a company won't explicitly say, okay, my strategy is 1, 2, 3, 4, 5. They won't tell you explicitly. So we can use the 5 P's to identify whether a company is having a strategy in its practice. So the first one, Henry Mintzberg says, strategy can be manifested as a plan. So this is the most common one. So you can see the companies has a plan here. So it's intended course of action, a guideline to deal with the situation. And strategy can also be applied. So a specific maneuver intended to outwit a component or competitor. So this is also the most popular definition, the most popular manifestation of strategy in our real practice is competitive strategy. When you mention strategy in business world, usually it refers to competitive strategy. But strategy can also be presented as a pattern, so a consistency behavior, whether or not intended. For example, between 1913 to 1920, Henry Ford, so the vehicle producer, the car producer, that was the most important industry in the last century, that is car manufacturing. So Henry Ford, in their company, the Ford company, they only produce the type of car that is black. So only black cars. So this is actually their strategy, but they don't say it's a strategy. But you can see there is a pattern, the consistency in the behavior. So this can also be identified as a strategy, even though it's not explicitly saying, okay, this is a strategy, or I have a plan to do that. Strategy can also be presented as position. For example, a means of locating an organization in its environment. So some companies, they will locate itself, position itself as some, I'm not targeting the mainstream market. I'm only targeting a small segment, what we call the niche market. So this is how a company positions itself. So this can also be understood as a company strategy. And strategy can also be seen as a perspective. So an ingrained way of perceiving the world. So this is less explicit. So for example, IBM and HP, they are both hardware producers, but they have different emphasis on their focus. For example, the IBM will emphasize marketing, but HP has more emphasis on their engineering. So this is an ingrained way of thinking, their perspectives. This can also be understood as a strategy. strategic management is particularly the analysis, decisions, and action an organization undertakes in order to create and sustain competitive strategies. So what we call competitive strategies is how you can outperform, differentiate from your competitors. So it relates to two very important questions for all the businesses. This first one is how should we compete and create such competitive advantages. The second one is how to create competitive advantages that are unique, valuable, and difficult to copy or substitute. Why do we need to think about difficult to copy and substitute? Because competitive strategy needs to last long. So if you just have the advantage, a competitive advantage for 1 year or two, that's not a good strategy. You need to be able to sustain your competitive strategy. So in summary, what is a strategy? Particularly, what is a competitive strategy? It is how you can beat your competitors and how you can beat them in the long term. So simple understanding. So let's get back to the specifics of digital strategy. So we talked a little bit last week, digital innovation, digital transformation, and we talked about the digital strategy is essential to a company who either want to achieve good digital transformation or want to compete as a digital business which has digital technology at the core of its value creation and capture. So digital strategy is essential for all the companies who need to implement digital technology. But there are different, you're probably seeing different types of strategies related to digital technology. So the first one you may have heard about is called IT strategy. This is a type of strategy that decides the technological infrastructure of the organization. So it ensures that the most appropriate technologies and best software and hardware standards are used in terms of cost efficiency and supporting the user needs. So we have at WEEK2, we have the IT department. So if we want to implement some new softwares like Microsoft Suite, we will need IT strategy. The IT strategy is more about the implementation of the digital infrastructure, the hardware and software. Other term you may have heard about is called IS strategy. It decides how IT is applied within an organization. It ensures that the IT deploys supports business strategies and that appropriate resources and processes are in place for the deployment to be effective. So this not only includes how you are going to implement hardware and software, it also includes how you are going to manage this whole processes of implementation to make it as effective as possible. The last one is our core concept, that is digital strategy. So it's not completely IT or IS strategy, even though there are some overlap between them. Digital strategy is specifically about creating digital edge than mere digital automation. Last week we talked about this. Digital strategy is not just about implementing one or two, information systems, implement a customer support system or decision-making system in your company. Digital strategy that combines digital information and physical resources in new ways, in the ways that can create and capture new values for the organization. So as you can see, compared to IT and IS strategy, digital strategy has a digital technology at the core of a company's value creation and value capture. Even though they have some overlap, because digital strategy is also about how you are going to implement your hardware and software. So if you look at the strategies present in a company, so you will see a company. This is our normal structure of an organization. So you will have your corporate level, so that's your executive level, and if you go down, you have different business units, and under different business units, you will have smaller functional areas under each business unit. So for example, at the most basic level, you will have your marketing group may have a marketing strategy. Your supply chain group may have a logistics strategy. your IT group, your IT department will have their IS or IT strategy. But all the strategies of your functional areas and business units, they need to be fully aligned with the overall business goals and plans, business strategy of your company at a corporate level. And digital strategy, as we said, because it's at the core of a company's value creation and capture. It's usually part of, or even for some companies, like we talked about the platforms last week. Digital strategy is actually their business strategy. So to achieve the alignment between your digital IS or IT strategies with your overall business objectives and actions is a continuing and a crucial topic for strategy development. Okay, so far, some basics about what strategy is. So now we know what it is like and what is areas that we need to consider when we are differentiating different IS, IT, and also digital strategies. What are the different roles in the organization? Now we are moving on to the development of strategy, that is strategy process. So we talk about strategy is about the long-term goals and objectives of a company, as well as the plans to execute it. The strategy process is specifically the development, the processes of developing and implementing strategy. So for digital strategy, that is how you implement your digital strategy. This is a simplistic approach to developing strategies. So very simplistic, linear way. So if you dissect the processes of developing strategy, you will see the first, of course, you need to analyze. You need to understand your company. And then you formulate your goals, formulate your plans, an initial version, and then you implement it. So analysis, formulation, implementation are two basic steps. So please be aware this is a simplistic version. So just for us to understand the fundamental steps in strategy processes. The complete full picture of strategy process can be more complex. But we are focusing on the three for us to understand how we are going through the strategy process one step by step. So our focus is to understand how digital strategy interact with the strategy process. So let's start from the analysis part. So to understand what a company, what I need, what are my goals, what I want to do. So, and also develop the plan for it. The very first step is to analyze, to understand yourself. So let's say if you have your organization, if you have a startup, so you are going to develop the goals for your startup. It's a long-term goals, not just for 1 year or two. If you want to develop the goals for your company, and you also want to design a plan to execute it. So let's say, what kind of information do we need? Everyone, think about it. If you are going to, you have a startup, you have an organization, you are going to develop a digital strategy for your organization. What do you need to know about your organization in the first place? Think a little bit. I'll try. So if you, sometimes I ask a question in our class. So if you have an answer, so feel free to raise your hand. I will be very happy. And if you don't have an answer, if you just don't know the answer, it's fine, totally fine. Just say, I don't know. So that's, it's better to be honest. So this is the strategy analysis, the start of developing a strategy, start of strategy process. So if you are going to design a strategy for your company, so what would you want to know about your company in the first place? Think about this. Do you want to know what your company works? So that is your internal resources and processes. What do I have? What processes, what products do I want to produce? What service do I want to provide? What resources do I have? what internal processes are present in my organization or not present. And the second aspect, of course, we need to understand our external environment. We need to understand what our customers want, what our suppliers want, and also what the regulators want. So this is our external environment. So simply, we can divide the strategy analysis into two aspects. The analysis of your external environment and the analysis of your internal resources and processes. So very simple. And we're starting from the analysis of your external environment. So what are the important external forces for our strategy analysis? For this 5 forces model, I believe some of you may have heard of or have read about or have learned from some of other lectures, some of other modules. But our focus today is particularly on how Porter's 5 forces model can be implemented for digital strategy processes, also in analyzing or evaluating digital strategy. So let's focus on this. So Porter's 5 forces model is a framework, it's a classical framework developed by Porter in 1985, and he further refined and improved it over time. So each of the 5 forces, as you can see in the graph, so affects a company's ability to compete in a given market. All of these 5 forces are external forces, so there's nothing about the company's internal processes or activities. So this model is an analytical tool to assess. So first, okay, if you want to know whether your company should remain or exit an industry. Second, how to improve your company's competitive position regarding each of these forces. So this is the main use of the Porter's 5 forces model. 2 purposes. So this model is very highly structured, popular in industry, and even though it has been there for over 40 years, it's still very popular because of its comprehensiveness and also structural analysis it can facilitate. It provides pointers for analyzing how digital technologies can influence important forces in the industry and can be used to improve a company's ability to compete in industry. So when relating to digital technology and digital strategy development, 2 functions, 2 purposes. First, you can use 5 forces model to understand, to analyze a company, your company's position in a digital market. For example, what is the position of my company in the digital gaming market? What is the position of my company in the online retailing market? You can use this for this purpose. The second purpose is you can use this model to evaluate how a company's implementation of specific digital technology can influence its competitiveness in the market. How digital technology can influence, either increase or decrease each of these 5 forces. So that's the 2 purposes, 2 functions you can use Porter's 5 forces model for. So let's start from the first one. That is the threat of new entrants. So this is an easy one. So new entrants, so that is newcomers, new competitors into a market. So these new competitors, they can erode the profits of established companies in the industry. So that's how they pose a threat to your company. So this kind of the level of threat of new entrants depends on the existing entry barrier and combined reaction from existing competitors. For example, the entry barrier for new entrants can come from, for example, economy of scale. So if the economy of scale is an economic concept, meaning like the more products you produce, the same products, the more products you produce, the cost you spend on each individual product will decrease. For example, if you produce a vehicle, a car, like 100 cars, the same car model. If you just produce 100, that's the cost of each car. Let's say it's $10,000. But if you use the same equipment, same machine, same facility, same factory to produce 10,000 same car models, then the cost of producing each individual car will decrease because you effectively used your resources to achieve the economy of scale. So the high capital requirements, if the market, you need to invest a lot, you need a lot of money to enter this market. This market also has too high entry barrier. So before, last week, we always considered that the AI training is a competition among tech giants because the large amount of money you need to spend on high-end GPUs. As we can see, things can be changing. So if the cost of purchasing such hardware can decrease, they can allow more startups to enter this market. High switching costs. If it's much more difficult for the customers to switch to a new company, new products will be much more difficult for the new entrants to enter the market. Limited access to distribution channels and also incumbent favored government policies. If the government policies favors the incumbents, it also makes the entry barriers higher. So these are the factors that can decide the level, the degree of entry barrier in market, and therefore the level of threat of new entrants. If the market has a high entry barrier, the threat of new entrants will be much lower. So this is the first force. And the influence of the government policy, here is an example. So if you see, if the government especially favors incumbents, you will see it's much more difficult for the new entrants to join the competition. So like what happens in 2022, that is the time when Uber tried to push into the Australian taxi market. As we know, Australia has a very strong union of taxi drivers. So the government policy at that time strongly favors the traditional taxi industry and taxi companies, taxi drivers, so tend to protect them. So they will require like rideshare platforms like Uber and other platforms to provide similar levels of benefits for the workers to allow them to enter the market. So this kind of favorable government policies for the incumbents can increase the entry barrier for new competitors like ride-sharing platforms to enter the traditional taxi industry. So this is an example of how the entry barriers can increase and threat of new entrants can be decreased by the government policy. So digital technologies, overall, you can see in our society today, it tends to lower the entry barriers. So why it happens? So if we can see previously, if a new company needs to establish itself, it needs offices, it needs all those kind of physical equipment, it needs the supply chain, it needs to interact physically with all its customers and also its suppliers. But today, if you have the digital technology, many of those businesses and product services can be provided and delivered online. So you don't really need a physical space. You don't need to rent an office. Sometimes you don't really need to leave the office. So people can work distantly. So they don't really need to meet each other. So this will actually save the cost of the new startups in terms of starting its businesses. So overall today, we see the digital technologies just overall. So if you look at specific areas, specific industry, you need to understand it more specifically. So digital technology overall tend to lower the entry barriers of many existing traditional markets. The second force is the buying power of buyers. So buyers, of course, it's easy to understand. People, it's a companies who purchase, companies or individuals who purchases. So buyers can force down prices. Its influence on the company's market position, company's position in this force of in market position in an industry is through forcing down the prices, bargain for higher quality or more services, and play competitors against each other. So this is how bargaining power of buyers can influence your company's market position. So its power depends on attributes of the market situation and the importance of purchases of that group. For example, a buyer group can be very powerful when its purchase is concentrated in large volume. If I buy a lot, of course, many suppliers will want this customer. So if and also the product purchases are standard and undifferentiated. If the products I want to buy are most companies can produce, there's no difference, minimal difference between the products. Then I will have no choices. So I will the buyer will be in a much stronger position. Also, it can pose a credible threat of backward integration. So backward integration is a situation that the buyer is so strong, it tends to take ownership or control of its suppliers. So especially if its suppliers is not like, it's not very good to get along, not very easy to get along with, this kind of buyers will want to purchase or get more control of the suppliers. For example, Starbucks. So we buy the coffee from Starbucks. But what we don't know is Starbucks actually has its own coffee bean farms in multiple countries. So instead of purchasing coffee beans, Starbucks literally, I just buy my suppliers of coffee beans because coffee beans is an essential resource. High quality coffee beans is essential for my production of coffee, my supply of coffee to end customers. So this is called backward integration. Is the buyers is so strong it purchases or even take more control of its suppliers. So this will further increase the power of the buyer. So if you look at how digital technology influence the buyer's power, so this force bargaining power of buyers. If you look at this one, we will see two different scenarios, two different situations. So on the one hand, we can see digital technology today can increase end users' powers like us. So we are called end users. We are the final buyers of the value chain. So as individuals, today we can compare prices across different websites. We can buy directly from the producers online. So we can also have many other efficient tools to ensure that we can get a good quality at lower price products. So in terms of us as end users, end buyers, our power is increased by the popularization of digital technology, by the emergence of digital technology, cell phones, mobile technology. But if you look at some buyers in the middle of the supply chain, let's say distributors or shopping malls. So these are not end buyers, they are the buyers. They buy the products from the producers and then sell it to us end users. For those buyers in the middle of the value chain, you will find their power actually decreased. Because today the producers, they can directly sell the products to us at lower price, save the middle step. So for this kind of shopping malls, or what we call the distributors, retailers, their power was actually decreased with the development of digital technology. So as we can see, when we are analyzing how digital technology influences the power of buyer groups, so we need to look at whether the buyer is located at the end of the value chain or in the middle of the value chain. So let's do it for the next force. So let's say this one is a bargaining power. The third force is a bargaining power of suppliers. So suppliers, so it's just so it's opposite to the buyers. Suppliers can threaten to raise the prices or reduce the quality of purchase purchase goods and services. This is their power, just opposite to the buyers. It also depends on the market situation and also importance of the suppliers of that group. And the supplier group is powerful when it is dominated by a few companies and its supply is concentrated. Its supply, this is, so if you are dominated by a few companies and your supply is concentrated, you are actually can buy a lot. So you have more power. So here, you can supply a lot. So you have more power in this market. And also if your supply products are differentiated, only you can supply this product. So I will still use the GPU example. Is currently, so GPUs are only produced by two major companies, NVIDIA and its competitor AMD. So these two companies literally kind of have a monopoly in the market. Their products are differentiated. But we know many of the tech giants are developing their own GPUs today. But we can say at the moment, the products of these two companies are differentiated in the GPU market. And also can pose a credible threat of what we call the forward integration. So this is mirroring the buyer's power conditions. So forward integration, as we can see from the example of Amazon Locker. So this is just mirroring the backward integration. Forward integration means that the supplier is so strong that it tends to buy its buyers, its distributors, particularly the distributors and retailers. So for example, Amazon Locker. Amazon sells a product. It is a supplier at the beginning of the supply chain. But it's used to deliver its goods, to deliver its products to its customer through other delivery companies. But later, Amazon made a decision. First is to develop its own delivery service. So now we receive most of our products ordered on Amazon, just directly from Amazon's delivery service. And another measure it implemented is to use the Amazon Locker. So you will find Amazon Locker in some of the convenience stores. So you don't need to pick up when it's your order is delivered. You can just pick up when you finish your study or finish your work. So this is process. This is the act of buying or integrating your distributors and your retailers. Then you can get more control of your distribution processes. So this gives the supplier, like Amazon, even more control and power over the whole value processes. So just now we talked about the bargaining power of buyers can be influenced differently by the development of digital technology. Let's look at the power of suppliers. So let's have a 3 minutes discussion, everyone. So let's think about this. How do you think the digital technology can impact the bargaining power of suppliers? So as we said, bargaining power of buyers and bargaining power of suppliers, they are literally mirroring each other. Think in this way, and also think from your daily life, based on your real life experience. Do you think the digital technology has increased the bargaining power of suppliers or decreased the bargaining power of suppliers? Or do we need to consider different suppliers specifically? Okay, 3 minutes. So you can think by yourself or talk with your classmates.